Hello everyone, today we will start with the session 3 of our rapid revision for JEE mains. Coming on to question number 1, it is the question from chemical kinetics chapter. Chemical kinetics. So for the reaction A plus B gives C, starting with different initial concentrations of A and B, initial rate of reaction were determined graphically in 4 experiments, right? So basically 4 experiments were conducted and following are the observations. The first one, they kept the initial concentration of A as 1.6 into 10 raised to the power minus 3 and B as 5 into 10 raised to the power minus 2, and the rate was obtained as 10 raised to the power minus 3. Similarly, in the second experiment, the concentration of A and B were changed and the rate was found to be different. Similarly, in third and fourth also, right? So what we need to do is to find the rate law for the reaction from the above data, right? So basically, we have to find here order with respect to A, order with respect to A and order with respect to B. These two things we have to find it out, right? So first we'll write the rate law. Rate law will be what? Rate law equals to rate constant into concentration of A raised to the power m, concentration of B raised to the power n, where m and n are order of the reaction respectively. Okay. So now we have to find out the value of m and n, right? To find out the value of m, basically we have to take two experiments such that the concentration of B is constant, right? Now here if you see in the first and second experiment, let us see, the concentration of B is the same, right, while the concentration of A is varying, right? So I will write R1 equals to K into 1.6 into 10 raised to the power minus 3 raised to the power m, and concentration of B is 5 into 10 raised to the power minus 2 raised to the power n. This is R1. Value of R1 is 10 raised to the power minus 3. For the second one, if I write down, it will be R2 equals to K into 3.2 into 10 raised to the power minus 3 raised to the power m into 5 into 10 raised to the power minus 2 raised to the power n, right? And the value of R2 is given as 4 into 10 raised to the power minus 3. Now what you have to do is basically you have to divide R2 by R1, right? So R2 by R1 will be equal to how much? 4 into 10 raised to the power minus 3 divided by 10 raised to the power minus 3, right? K and K will get cancelled out, and 5 into 10 raised to the power minus 2 raised to the power n, 5 into 10 raised to the power minus 2 raised to the power n will get cancelled out here, right? And we are left with 3.2 into 10 raised to the power minus 3 raised to the power m divided by 1.6 into 10 raised to the power minus 3 raised to the power m, right? So dividing the two, we get 4 equals to 3.2 divided by 1.6, that will be 2 raised to the power m, right? And we know that 2 raised to the power 2 is equal to 4. So the value of m we are getting here is 2. That means the order of the reaction with respect to A is what? 2. Okay. Now we have to similarly find out the order of the reaction with respect to B. So we have to choose such experiments that in which the concentration of A is constant. Now if you see here 1.6 in the first and the third experiment, concentration of A is constant and concentration of B is changing, right? So we will write down R1 equals to K into 1.6 into 10 raised to the power minus 3 raised to the power m, and this one will be 5 into 10 raised to the power minus 2 raised to the power n. R1 is given as 10 raised to the power minus 3. R3 will be given as, which is having a value of 2 into 10 raised to the power minus 3, will be given as 1.6 into 10 raised to the power minus 3 raised to the power m, and 10 raised to the power minus 1 raised to the power n. Now you have to divide R3 by R1. That will be equal to 10 raised to the power minus 3, 10 raised to the power minus 3 will cancel out, k and k will get cancelled out, this and this will get cancelled out. So you are left with 2 divided by 1 equals to 5 into 10 raised to the power minus 2 raised to the power n divided by 10 raised to the power minus 1 raised to the power n. So that will become equal to how much? 5 into 10 raised to the power minus 2 plus 1 raised to the power n. That means what? 2 divided by 1 will give you 5 into 10 raised to the power minus 1 n. Okay. Yeah, R3 is having a value of 2 into 10 raised to the power minus 3 and this is having a value of 10 raised to the power minus 3. Okay, just a second. Here it will be 10 raised to the power minus 1. Sorry. Here it will be 10 raised to the power minus 1 to the power n because we are writing R3 here, right? 10 raised to the power minus 1 raised to the power n and here will be 5 into 10 raised to the power minus 2 raised to the power n. Now, this will be equal to how much? 1 upon 5 into 10 raised to the power minus 1 plus 2, that will be equal to 2 by 1 equals to 10 raised to the power plus 1 divided by 5, right? Or you can do it vice versa also. 1 by 2 will be equal to how much? 5 divided by 10. So 1 by 2 will be equal to how much? 0.5 raised to the power n, right? So 1 by 2 can also be written as 0.5. So 0.5 equals to 0.5 raised to the power n. So n will come out to be 1. I hope it is clear. What we did is we write down the rate law for R1 and R3, right? And then we divided R3 by R1. So here you can see that this and this get cancelled out, k and k gets cancelled out, 10 raised to the power minus 3, 10 raised to the power minus 3 gets cancelled out. Now you are left with 10 raised to the power minus 1 raised to the power n and this value, that is 5 into 10 raised to the power minus 2 raised to the power n. Now when you will solve this particular thing, you will get the value of n as 1, right? So the value of m that you are getting is 2 and the value of n that you are getting is 1. That means order with respect to A is 2 and order with respect to n is 1. So answer for this question will be B. Question number 2. Two first order reaction have half-life in the ratio 3:2. That means let us say for reaction number 1, the half-life is 3K, capital K, not the rate constant, it is the normal constant because it is the ratio, so we have to apply the constant also here. And T half 2 for the reaction number 2 is given as 2K, right? I am again repeating, this K is not the rate constant, it is the constant for the ratio basically, right? Because we represent the rate constant as small k. Now calculate the ratio of time intervals T1 ratio T2. So what is T1 basically? T1 is the time period for completion of 25% of the reaction 1 and T2 is the time period of completion of 75% of the reaction second. Okay. So now here if you see that, first we will calculate the time period for 25% completion. Okay. So that will be written as it is a first order reaction, so it will be log of A naught by AT will be equal to KT upon 2.303, where K is the rate constant here, right? So log of, first it is saying we are finding out T1 basically, right? So first this is saying that it is the time period for 25% completion. That means what? That 25% has been decomposed and the left percent is 75%. So log of 100 by 100 minus 25. Why? Because 25% has been decomposed, will be equal to rate constant K into time divided by 2.303. Now we will take this time as T1, right? Now this will become equal to log of 100 by 75 will be equal to K. Now what is the value of K here? If you find out, for a first order reaction, K equals to 0.693 divided by T half. So you can put the value of T half from here, that is 3K. So it will become equal to 0.693 divided by 3K, capital K, into 2.303 into T1. So the value of T1, you will get it as T1 equals to 3K into 2.303 divided by 0.693 into log of 100 divided by 75. So this is the expression for T1. Okay. Similarly, now we have to calculate the expression for T2. For T2, again you write down log of A naught by AT will be equal to KT upon 2.303. So this will become equal to log of, now see here, T2 is the time for 75% completion of the second reaction. So this will be 100 divided by 100 minus 75 will be equal to rate constant K into time T2 divided by 2.303, or you can write down T2 as 2.303 into log of 100 divided by 100 minus 75 divided by K. Now we know that half-life of the reaction equals to 0.693 divided by rate constant, right? Because it is a because we are here taking the second reaction basically, and the half-life for the second reaction is 2K. So K will be equal to 0.693 divided by 2K, capital K, right? So we will put the value of K here, 2.303 divided by 0.693 into 2K into log of 100 minus 25, right? So we have obtained the expression of T1 and T2, right? Now what we have to do, we have to find the ratio of the two, right? So you will find out the ratio. See here, T1 can be written as 2.303 divided by 3K log 100 by 75, and T2 can be written as 2.303 2K log 100 by 25, right? So we have to divide the both. See here, when you will divide the both, you will get as 2.303 gets cancelled, K and K gets cancelled. Find out the value of log 100 by 75, find out the value of log 100 by 25. And when you will divide the two expression, you will get the answer as 0.311 ratio 1. Okay, so the answer for this particular reaction is A. I hope it is clear. See, first we need to find out T1 expression, then we need to find out T2 expression, then we need to divide the both, right? And how will you find the expression for T1? You just take it as half-life as 3K and take half-life as 2K basically, right? Where K is the capital K, that means the ratio constant basically, right? So we know that half-life for the first reaction will be 2K and half-life for the second reaction will be what? 3K, right? Now you have to put the values of log A naught by AT equals to KT. So when you need to find T1, put it T1 here, And K, what will be K? We know that rate constant equals to 0.693 divided by T half, and T half is what? Basically 2K for the first reaction. So this will be log of 100 divided by, because it is a 25% completion, that means 75 will be left, equals to K will be what? 0.693 divided by 2K into T1. Similarly, for that you can get it as log of 100 by 25. For T2 you can write it as 0.693, sorry, it is 3K and it is 2K. 3K here and 2K here. So 2K into T2. So find out the ratio by dividing the two equations. Okay. You will get the answer as 0.311 ratio 1. Half-life of a reaction is found to be inversely proportional to the cube of initial concentration. The order of the reaction is. Now we know that half-life is directly proportional to 1 upon A naught raised to the power n minus 1. Right. Now this value is already given as cube. Right. That means n minus 1 is equals to what? 3. So n will be equal to what? 3 plus 1, that is equals to 4. Right. So for question number 3, the order of the reaction is found out to be 4. A first order reaction is 50% completed. That means half-life time is given as 20 minutes for 27 degrees Celsius, or you convert it into Kelvin, that will be 300 Kelvin. And T half is 5 minutes when you increase the temperature to 47 degrees Celsius, or basically 320 Kelvin. Now you need to find out the energy of activation of the reaction, right? So we have studied the Arrhenius theory, that is K equals to A e raised to the power minus EA by RT, where EA is the activation energy and K is the rate constant of the reaction, right? So we can write it as K1 equals to A e raised to the power minus EA divided by RT1, because A will be the same if you increase the temperature, and activation energy will also be the same if you increase the temperature. There is only difference in the rate constant with the temperature. Okay. So K2 will be equal to how much? A E minus EA by RT2, right? Then if we divide both, then we will able to calculate the EA value, right? Now the question is that from where you will find out the value of K1 and K2. So we already know that for a first order reaction, T half is equal to 0.693 divided by K. So K1 will be equal to 0.693 divided by half-life at the temperature 300 Kelvin, right? So this will be, K1 will be equal to 0.693 divided by 20 minutes. Similarly, K2 will be equal to 0.693 divided by 5 minutes. Okay, where T1 is 300 Kelvin and T2 is 320 Kelvin. So we have got the values of K1 and K2. Now we will substitute the value of K1 and K2 here. We will substitute the value of K1 and K2 here. Meanwhile, you can solve it in your notebook. Now see here, K1 will be how much? 0.693 divided by 20 will be equal to A e raised to the power minus EA by R. What is T1? 300 Kelvin into 300. K2 will be equal to 0.693 divided by 5 will be equal to A e raised to the power minus EA by R into how much? 320. Now you have to divide the two, right? When you will divide the two, you will get it as, see here, you will get it as T half by T dash half is equal to 4, right? See here, T half will be equal to 0.693, or I'll do it in the other way also. K1, K2 by K1 you have to find out, let us say, right? So this will be equal to how much? 0.693 divided by 5, 0.693 divided by 20 will be equal to e raised to the power minus activation energy R into 320 divided by A e raised to the power minus EA by R into 300. So A and A will get cancelled, 0.693, 0.693 will get cancelled, right? You are left with that 20 divided by 5 is equal to e raised to the power minus EA, just a second. Yeah, when you will divide the two, you will get it as 20 by 5 will be equal to e raised to the power minus EA by R into 320, e raised to the power minus EA by R into 300, right? Now 20 by 5 is how much? Is it equal to 4? And you can, as the bases are same, so you can just subtract the power. So it will be EA by R 1 upon 300 minus 1 upon 320. Why? Because here activation energy is also common and R is also common here, right? So we are left with this. Now what we have to do it, you can just take ln of both the sides. So that will be equal to ln of 4 will be equal to activation energy by R 1 upon 300 minus 1 upon 320, right? That will be equal to how much? Ln of 4 is equal to EA by R 1 upon 300 minus 1 upon 320. Now solve it. You will get 320 minus 300 will be 20 divided by 300 into 320 into activation energy into 8.314. The value of R will be equal to ln of 4, right? Now the value of ln of 4, it may be provided to you in the examination itself, okay, or you can also simplify it as ln of 2 square, or you can also write it as 2 ln 2, right? Now you can put the value of ln 2 and just multiply 2 with it. So the value of activation energy that you will be getting here will be 55.14 kilojoule per mole. This is how you can solve this particular question. Mathematical representation for T1 by 4 life for first order reaction is given by. So T1 by 4 is basically the time at which 1 by 4th of the reaction has been completed, and the amount of reactant that will be left here is 3 by 4. This is very important. See, T1 by 4 will mean that 1 by 4th of the reaction has been completed. T3 by 4 will mean that 3 by 4 of the reaction has been completed. That means 3 by 4 of the total product has been decomposed into the, total reactant has been decomposed into the product itself, right? So here if you see, T1 by 4 is the time taken for 1 by 4 decomposition of the reactant, and the left amount of the reactant will be 3 by 4, right? Now as it is a first order reaction, therefore it will be log of A naught by AT will be equal to what? KT. Now we are taking T1 by 4, that means log of 1 divided by 3 by 4th will be left. So 3 by 4 will be equal to K into T. Now T is what here? T 1 by 4. So this will be equal to log of 4 by 3 equals to K into T 1 by 4, or it can also be 1 by K log 4 by 3 will be equal to, yeah, this is 2.303. sorry, because we are taking log, 2.303 should be there. If you are taking ln, then no need to write the 2.303 factor, right? So it will be 2.303 by k log 4 by 3 will be equal to how much? T 1 by 4. So now you can match your answer. Your answer is C. That is T 1 by 4 equals to 2.303 divided by rate constant log 4 by 3. A first order reaction is half completed in 45 minutes. That means half-life of that first order reaction is how much? 45 minutes. How long does it need for 99.9% of the reaction to be completed? Right. Now 99.9% of the reaction is completing means what? That if you are having 100 moles of the reactant initially, that means A naught, out of it 99.9 moles have been decomposed and you are only left with 0.1 mole of A naught. So this means that 0.1 is the amount of the reactant left after the completion of 99.9% of the first order reaction, and T half is given here. So you need to find out that what is the time required for 99.9% completion. So this will be log of A naught by AT will be equal to KT upon 2.303. So this will be log of 100 minus 100 upon 100 minus 99.9 equals to KT 99.9% divided by 2.303. Now we know that what is the relationship between half-life and the rate constant of a reaction? K equals to 0.693 divided by T half. So K will be equal to 0.693 divided by, what is T half here? 45 minutes. Substitute the value of K here, you will get log of 100 upon 100 minus 99.9 will be equal to 0.693 divided by 45 into 2.303 into T 99.9%. So now you can calculate and find out the value of T 99.9%. See here, when you will calculate this stuff, you can get the answer as 7.5 hours. Remember that you need to convert the time that you will be getting here will be in minutes, right? And you have to give the answer in hours. So remember to divide the answer by 60 basically, so that you can get the time in hours. So the answer you will get here is 7.5 hours. I hope it is clear. Question number 7. For a first order reaction, A is giving products. The concentration of A changes from 0.1 molar to 0.025 molar in 40 minutes. That means in 40 minutes time equals to 40 minutes. A naught was 0.1 molar and AT was 0.025 molar. Now it is asking the rate of the reaction when the concentration of A is 0.01 molar. So rate is equal to K into A basically, because it is a first order reaction, right? Now we have to find out the rate when the concentration of A is 0.01 molar. That means rate will be equal to K into 0.01 molar. Now the value of K needs to be found out to determine the rate of the reaction, right? And that K value we will find out from this data. So again apply the equation for the first order reaction. Log of A naught by AT will be equal to KT upon 2.303. So this will become equal to log of A naught is 0.1, AT is 0.025 equals to K is what? That we have to need to find out. T is 40 minutes divided by 2.303, right? Now you have to find out the value of K here. Now when you will find out the value of K here, that value needs to be substituted here, and then you can find out the rate of the reaction when the concentration of A is 0.01 molar. Okay. So when we will solve it, you will get the answer as K will be equal to 2.303 into 0.6020 divided by 40, or you can get the value of K as 3.47 into 10 raised to the power minus 2 minute inverse, right. Now substitute this value in the equation, that is rate equals to rate constant into concentration of A, and then you can get the answer as 3.47 into 10 raised to the power minus 4 molar per minute, right. So answer for question number 7 is B. Okay. So this question is from ionic equilibrium. Ionic equilibrium. See here, the pH of a solution whose H plus concentration is 3.0 into 10 raised to the power minus 4 molar. Now this is a very simple question. Just you need to remember a simple formula, that pH will be equal to minus log of H plus. That is minus log of 3 into 10 raised to the power minus 4. That will give you what? pH basically, right. So if you tend to find out, if you solve this particular expression, minus log of 3 into 10 raised to the power minus 4, you will get the pH as 3.523. So pH here, the answer will be D. Okay, just we have to apply the simple formula, minus log of H plus will be equal to pH. Question number 9. pH of 1 molar aqueous solution of a weak acid HA is 6. Now here it is given that the concentration is given as 1 molar, first point. Second point is that pH is given as 6. That means the concentration of H plus will be equal to how much? 10 raised to the power minus 6 molar, as pH equals to minus log of H plus. So from here we can find out the concentration of H plus basically, right. Now it is saying its dissociation constant is, that means you need to find out Ka here, right. So we know that Ka equals to what? C alpha square divided by 1 minus alpha, where alpha is the dissociation constant. So we are already having the value of concentration, that is 1 molar here, but we need to find out the value of alpha, right. So how will you find out the value of alpha? Let's see. HA on dissociating, because it is a weak acid basically, so it is partially dissociating into H plus plus A negative. So at time equals to 0, C 0 0, after some time C minus C alpha, C alpha, C alpha. Now we know that H plus concentration is what? Basically C alpha, right. And we are already knowing that H plus concentration is what? 10 raised to the power minus 6. From the value of pH we have calculated this. So put C alpha equals to 10 raised to the power minus 6. Equate the two, right. Now here you can see that C is what? 1 molar. So alpha will be equal to 10 raised to the power minus 6 divided by 1, that will be equal to 10 raised to the power minus 6 only. Now you substitute the value of alpha in the dissociation constant of acid. So C is what? 1 into 10 raised to the power minus 6 whole square divided by 1 minus 10 raised to the power minus 6. Now we can neglect the value of alpha, because alpha is much smaller than that of 1. Okay, it is 0.000006 basically, right. So we can neglect the value of alpha here, and we are left with that Ka equals to 10 raised to the power minus 6 to the power square, that will be equal to 10 raised to the power minus 12, right. So the value of dissociation constant will come out to be 1 into 10 raised to the power minus 12. So answer for question number 9 is A. Question number 10. 1 liter of a buffer solution containing 0.01 molar ammonium chloride, that is the salt basically, and 0.1 molar NH4OH, that is the weak base, having pKb of 5, has pH of. Now we need to calculate pH here. So straight away we are going to apply the Henderson-Hasselbalch equation. So what is the Henderson-Hasselbalch equation? POH will be equal to pKb plus log salt by base, right? So we have to calculate the pH, right? Here POH will be equal to, what is pKb? 5 plus log, what is the concentration of salt? 0.01 or 10 raised to the power minus 2 divided by, what is the concentration of base? 0.1. So this will be 10 raised to the power minus 2, 10 raised to the power minus 1. You can write it another way also. POH will be equal to 5 plus log of 10 raised to the power minus 1. That will be equal to, POH will be equal to 5 minus 1, that will be equal to 4. But we have to find out the pH. See the question here. Don't straight away mark the answer as 4, right? It will be wrong because it is asking about pH and we have calculated POH now. So pH plus POH is equal to what? 14 basically. So the value of POH is coming out to be 4. So the value of pH here is what? 10, right? So the answer here is 10. Question number 11. For preparing a buffer solution of pH 6 by mixing sodium acetate and acetic acid. So this is the salt and this is the weak acid. We are making a buffer of it and pH is given as 6. The ratio of the concentration of salt and acid should be, and the value of K is given, right? So again you apply the same equation, that pH equals to pKa plus log salt by acid, right? So pH is given as 6, pKa plus log of salt by acid. This ratio we need to find it out, right? So we have to find out the value of pKa first. So Ka is what? 10 raised to the power minus 5, and pK is what? Basically minus log of Ka. That means minus log of 10 raised to the power minus 5. That will be equal to what? Basically 5, right? So this will be 6 equals to 5 plus log of salt divided by acid. Okay, so 6 minus 5 will be equal to 1. So 1 will be equal to log of salt divided by acid, and we already know that log of 10 will be equal to 1, right? So salt divided by acid ratio will be equal to 10, or basically 10 is to 1. So the answer for this particular question should be B here. Okay, you can have a look at the question and then we'll solve the next question. Question number 12. A solution of ammonium chloride and ammonia has pH of 8, right? pH of 8 will mean what? That H plus ion is having a concentration of 10 raised to the power minus 8. Now, which of the following hydroxides may be precipitated when this solution is mixed with equal volume of 0.2 molar of metal ion? Now, it is clear that if you take barium, if you take magnesium, iron, calcium, its concentration is kept constant, that is 0.2 molar, right? And the H plus value that we are getting here is 10 raised to the power minus 8 basically, right? But here if you see that there are hydroxides ion present, right? So what will be POH basically? 10 minus 8, that will be equal to 2. That means concentration of OH minus, we already know that minus log of OH minus is equals to POH. So minus log of OH minus will be equal to what? 2. So OH minus concentration will come out to be 10 raised to the power minus 2, right? Now the question is, which of the following hydroxides may be precipitated? Now for precipitation to occur, we know that ionic product should be greater than that of the solubility product. This we need to state, right? So solubility product is already given. We need to calculate the ionic product. Ionic product for A, B, C, D will be same. Why? Because the concentration of OH is also same and the concentration of the metal ion is also the same. And here if you see that, 2 OH minus are there in each salt, in each base basically, right, in each of the hydroxides. So the ionic product we have to calculate it commonly. So what is the ionic product basically? For example, if you write it for barium hydroxide, let us say, ionic product will be same for ABCD, right? So it will be what? Concentration of barium into concentration of OH minus to the power square will be the ionic product. Similarly, you will calculate for magnesium hydroxide, that will be magnesium OH minus square. For ferrous hydroxide, it will be iron OH minus square. For calcium hydroxide, calcium OH minus square. So these ionic product will come out to be same because the concentration of barium, magnesium, iron and calcium are what? 0.2 molar. While if you see OH minus, the concentration was 10 raised to the power minus 2. So it will become commonly the ionic product of all the 4 will be 0.2 into 10 raised to the power minus 2 raised to the power 2. That will come out to be basically what? 0.2 into 10 raised to the power minus 4. Okay, so this is the ionic product basically of all the hydroxides. Right. So now you have to find out the value basically. I think I have done a mistake, just a second. Yeah, pH is equal to what? 8 and pOH will be equal to 14 minus 8, sorry. pOH will be equal to 14 minus 8, that will be equal to 6 basically. So the concentration of hydroxide ion will come out to be 10 raised to the power minus 6, not 10 raised to the power minus 2. I by mistake took it as 10, sorry. Okay. So here afterwards the OH minus will be 10 raised to the power minus 6 molar. Okay. Now similarly you calculate the ionic product of all these species. So that will be concentration of iron into hydroxide square or concentration of barium into hydroxide square, right? So that will come out to be commonly as 2 into 10 raised to the power minus 13. Now we know that for the hydroxide to be precipitated, basically ionic product should be greater than that of the solubility product, right? So solubility product is given here, ionic product we have calculated it common, that is 2 into 10 raised to the power minus 13. So it will be how much? Yeah, so we have to see that ionic the solubility product should be less than that of 2 into 10 raised to the power minus 13, right? Now here if you compare, solubility product is greater, here also if you compare, solubility product is greater, calcium hydroxide if you compare, solubility product is greater, but for iron hydroxide if you see, that is ferrous hydroxide, if you see the solubility product comes out to be 8.1 into 10 raised to the power minus 16, which is less than that of the ionic product that we have calculated, that is 2 into 10 raised to the power minus 13. So the answer for question number 12 will be C, because only for this particular hydroxide the ionic product is coming out to be greater than that of the solubility product. Question number 13. How many grams of calcium oxalate will dissolve in liter of saturated solution? KSP is given as. So we have to find out the solubility basically, right? So here if you see that KSP is equal to how much? X raised to the power x, y raised to the power y, s raised to the power x plus y. For calcium oxalate, if you see x and y are 1 and 1. So this will be 1 raised to the power 1, 1 raised to the power 1, solubility raised to the power square. That will be equal to what? KSP. Okay, so KSP is given as 2.5 into 10 raised to the power minus 9 will be equal to S square. So you have to find out the square root of basically 2.5 into 10 raised to the power minus 9 to find out the solubility, and the solubility that you will obtain by square rooting this type will be in mole per liter. Will be in what? Mole per liter. Right. So we have to convert it into gram per liter. First we will calculate the solubility in mole per liter. It will come out to be 0.0064 5 into 10 raised to the power minus 5 mole per liter. Right. This is the square root of 2.5 into 10 raised to the power minus 9. So this value you will get. Right. Now you have to find out the solubility in gram per liter, let us say. So what you will do here, that 5 into 10 raised to the power minus 5 into molar mass will give you the given mass. Because what is basically number of moles given mass divided by molar mass, right? So if you multiply number of moles by molar mass, you can get out the given mass. So here it will be 5 into 10 raised to the power minus 5 into 128. 128 is the molar mass of calcium oxalate, that is calcium will be 40, 12 into 2 it will be 24, and 16 into 4 it will be 64. So it will be coming out to be 128. Right, 128 gram per mole. So when you multiply this value by 128 gram per mole, you will get 0.0064 grams. That means this many amount of calcium oxalate you need to dissolve in a per liter solution. That means in 1 liter solution that is saturated. Okay, so the answer here is question number 13. The answer will come out to be 0.0064 grams. Question number 14 is from equilibrium chapter. 3 moles of PCl5 are heated in a closed 3 liter vessel. At equilibrium, PCl5 is 40% dissociated into PCl3 and chlorine. Calculate the equilibrium constant. Now write down the equation first. PCl5 will give you what? PCl3 plus chlorine basically. Right. Now at time equals to 0, 3 moles are present, 0, 0. Now 40% is dissociated, that means alpha is equals to 0.4, right. So this will be 3 minus C alpha. So this will be 3 minus 3 into 0.4, C alpha 3 into 0.4 and C alpha, that is 3 into 0.4. Now we have to calculate the equilibrium constant. So equilibrium constant will be what? Equilibrium constant will be equal to product of the concentration of the products and divided by the reactant concentration PCl5, right. So if you calculate this, this will be 3 minus 1.2, this will be 1.2, this will be 1.2, this will come out to be 1.8 basically, right. So these are the number of moles, but you need to find out the concentration for finding out the equilibrium constant. So you will divide it by the volume itself. So this will be, because concentration is what, basically number of moles divided by volume of solution. So this will be 1.8 divided by 3, 1.2 divided by 3, 1.2 divided by 3. Now you put the values here, it will be 1.2 divided by 3 into 1.2 divided by 3 divided by 1.8 divided by 3. Now when you will solve this particular thing, you will get the value of K equilibrium itself. Okay. See here. So the answer that you will be getting for the equilibrium constant is 0.267. Here if you see, first what we did, we calculated the number of moles of PCl5, PCl3 and chlorine at equilibrium. So for PCl5 it was 1.8, for PCl3 and chlorine it was 1.2 moles each. Now volume is coming out to be 3 liter. So for PCl5 it will be 1.8 divided by 3. For PCl3 and chlorine it will be 1.2 divided by 3, and K equilibrium will come out to be 0.4 into 0.4 divided by 0.6, then the answer will come out to be 0.267 basically. Okay. Question number 15. The conditions favorable for the reaction 2SO2 plus O2 will give you 2SO3. Delta H0 is given as minus 198 kilojoule. So it is asking about temperature and pressure basically, right. So if you see here that the delta H value is negative, so the temperature should be decreased. Why? Because it is a exothermic reaction. So exothermic reactions are favored at low temperatures. So the temperature should be low. What about the pressure here? So if you take the pressure here, for example, first you will calculate the change in number of moles of gaseous species. So it will be what? 2 minus 2 plus 1, that is 3, that will come out to be minus 1. That means if you decrease the pressure basically, right. So according to the Le-Chatelier's principle, the reaction will move to the side where there are more gaseous reactants, that means backward reactions, but we need to move the reaction forward basically, right. So if you increase the pressure, that means at high pressure, according to Le-Chatelier's principle, the reaction will move in the direction where there are less amount of gaseous species present. So here if you see, only 2 are present, 2 moles are present. Here if you see, 3 moles are present. So if you increase the pressure, basically the reaction will move on to the forward direction, right. So the conditions favorable for this particular reaction will be low temperature and high pressure. Low temperature, why? Because it is an exothermic reaction, and high pressure, why? Because according to Le-Chatelier's principle, if you will increase the pressure, the reaction will move to that side or to that direction in which the gaseous species are less, right. That means in the forward direction. Question number 16. For the reaction PCl3 plus chlorine giving PCl5, the value of Kc at 250 degrees Celsius is 26. The value of Kp at this temperature is, now we know the relation of Kp and Kc, Kp equals to Kc RT to the power delta Ng. Now do not give temperature as 250 degrees Celsius, rather convert it in Kelvin, that is 250 plus 273. That will come out to be how much? 523 Kelvin, right. So temperature is what? 523 Kelvin. Now delta Ng, if you see, 1 minus 2. So this will be equal to 1 minus 2, that will be equal to minus 1 here, right. R value will be 0.0821 if the Kp is found out in atmosphere, and if it is given in bar liter basically, then you will keep it as 0.08314, right. So we will calculate it in atmosphere first. Temperature is 523 Kelvin, Kc is given as what? 26. Now you apply the values in the formula. It will be given as Kp equals to 26 into 0.0821 into 523 raised to the power minus 1. That will give you the answer as 0.61 atmosphere inverse. That is, answer for question number 16 is B. I hope the questions are clear with you. So that's all for today. Thank you.